Naming organic compounds.
Hello everyone. Are you having trouble with naming organic compounds, or are you confused on how they differ from each other? Well, don't worry. I am your captain for today's no knowledge. We'll help you to work with it. But first, let's define organic compound. Once upon a time, there was an atom called carbon. Carbon was characteristically considered as one of the unique atoms. Why? Aside from the idea that it can form very stable molecules that range in size. Also, carbon can bond with other atoms to create somewhat an endless possibility of organic compounds. Amazing, isn't it? But how is it possible? Well. Simply because organic compounds contain carbon, and it's good to keep in mind that almost all organic compounds also contain hydrogen. But how does the carbon atom relate to the process of naming organic compounds? Basically, the number of atom carbon holds the key to determine the process. Begin our proper discussion. Are you guys ready in unfolding this? Then, here we go. In naming, we should be aware that at the most basic level there are three components to be considered. The prefix, suffix and its root. Naming actually gets complicated, but we can start applying the 6 steps to all compounds. Naming actually gets complicated, but we can start applying the 6 steps to all compounds such as alkane, alkene and alkyne by following the IUPAC rules to ensure that it will be named correctly. But before proceeding to the steps, let's differentiate together the alkane, alkene, and alkyne from each other. Alkanes have a single bond between carbons. To quickly recognize this, it has a general formula of CnH2n plus 2. Alkenes contains double bonds between carbons. A quick way to recognize an alkene is through its general formula of CnH2n. On the other hand, alkynes has triple bond with general formula of CnH2n minus 2. First step, locate the longest chain or determine it in our compound. For example, CH3CH2CH2CH3. So as you can see, the example actually contains single bonded carbon. On the other hand, locating the number of carbons can be done by counting the carbon within the chain. 1, 2, 3, 4.